So we've been looking at exponents, and so this is like day 3 of looking at negative exponents, okay, and negative exponents and exponents of 0, and now applying them more and more to variables as well as just numbers. The learning goal today was just on numbers, 5 to the 0, negative 5 to the 0, in brackets, negative 5 to the 0, all those different kinds of cases. But what happens when you start adding variables into the mix and start, making things a bit more complex? That's what we're looking at. So our instructions are simplify and express each answer with positive exponents only. This is important because when you have a variable, you can't evaluate it. So we will often simplify to get rid of the negative exponents. And really, quite frankly, we're doing this just to practice working with negative exponents. Okay? It doesn't mean that in mathematics you always do this. There's no rule. This is just for us to practice working with exponents. Does that make sense? So first question. Can you see it now? X to the 3 over x to the 8. Can you see that? That's as far as I can zoom in. Good enough? It's going to have to be. X to the 3 over x to the 8. What's the rule when I subtract powers of the same base? Pearson, do you remember? When I divide powers of the same base? What did I say? Subtract the exponent. So this is equal to x to the 3 minus 8. You don't have to show that step. But that is x to the negative 5, nice. But our instructions say no negative exponents. So what do I do with that negative exponent?
You would flip it and change it to a positive.
Flip it and change it to a positive. So by flip it, we mean we're taking the reciprocal. So we're flipping the x, or the base, which is in the top or the numerator of a fraction. We're flipping it down to the bottom and change the exponent to a positive. What is the thing that people think happens at this stage? Negative x to the 5. Wrong. Wrong, wrong, wrong. Slam the table to make sure everybody remembers it's wrong. Don't do that. Okay? Any questions? Different from a negative base. Negative exponent is different, very different from a negative base. Remember, we talked about terminology on the first day of this stuff. What's the base? What's the exponent? That kind of thing. That's why it can be important to have terminology for those things. Okay, let's move on. I'm going to write this out in long once, so you have an example of it that you can refer back to. If you ever get yourself confused, like how did we go from this step to this step? I don't understand. I'm not following. Look back at this one example if you write it all out as well. So we don't typically write it out this long, but it can be useful to remind us of what's actually happening. When I have two brackets side by side, what does that mean? We're multiplying. So this is this times this. How do I multiply? They're both called monomials, by the way, but don't worry, you don't need to know that. How do I multiply monomials? Zach, what do you think? If they were binomials, I would. If it was something plus something, then I would have to expand them like that. But since there's only one thing, like one whole thing inside the bracket altogether, no adding or subtracting, I don't need to do that. Ellie, what do you think?
Can you take out a common factor?
Again, it might be possible to do that. We're multiplying here, so we wouldn't talk about a common factor. Again, that would be when we're adding, but that's not what we want to do. I'll show you. Here's what we want to do. I'm just going to do this first. I'm going to do the numbers with numbers, and A's with A's, and B's with B's. That's what I'm going to do. And I'm going to do this once where I line them up. So I've got negative 3 times 2 times a cubed times a cubed times b cubed times b to the negative 2. This is not like terms, but it's sort of like that might help you to think I put like things together, numbers together, A's together, B's together, C's together, X's together, Y's together, and then multiply them. Does that make sense? Well, if it doesn't make sense, that's kind of too bad, I guess, because we're moving on anyway. But now I can look at this and I can say, so what is negative 3 times 2? Negative 6. And what is a cubed times a cubed? Multiplying powers of the same base, you add the exponents. So this is times a to the 3 plus 3. Again, you don't need to write that down, but we're going to this time. And then times b to the 3 plus negative 2, which is 3 minus 2. So this is equal to negative 6 a to the 6 b to the 1. 3 minus 2 is 1. You don't need to write the 1, but it is 1. If you were doing this on a test, neither of those two steps are needed. You could go straight to the answer if you know how to do it. But again, we wrote this out so it explains and illustrates what we did, why we did it, how it all works, how we got to that last step. Does that make sense? Yeah? And you've seen this before. And again, throughout the course, you are rarely going to see that kind of thing pop up. We're doing it now to practice these rules. But when we start applying it, usually it's with way simpler expressions. Okay. So this is 3x squared y to the negative 6 all squared. Somebody remind me what an exponent does. Yeah, it does. That's one way of thinking about it. Very good. Yep. But just in general, what's an exponent? Like if I do 5 squared, what does that mean? Tanner? 5 times 5. Whatever the thing is of the exponent times itself that number of times. So if I had something squared, it's that something times that something, no matter what is in those brackets. So another way of thinking about this is 3x squared y to the negative 6 times 3x squared y to the negative 6. Don't forget, that's always what we're doing. And whether you think of it this way or you think of it the way that Ali said, which is like the 2 goes into everything inside, they're both going to get you to the same place. Because this is like 3 squared, which is 9, x squared all squared, y to the negative 6 all squared. So 3 squared, or 3 times 3 is 9. And then x squared all squared, I multiply the exponents. So that's x to the 4. And then y to the negative 6 all squared. What's that going to give me? Why did you get 36? Oh, yeah, that's true. But it's not the exponent squared. It's already in an exponent. So what do we do? Power of a power. If it was like this is a really good point. If it was like this, negative 6 squared, absolutely is 36. But it's actually y squared. So what do we do?
Would it be negative 36y?
Nope.
Oh, no, I'm sorry, negative 12y.
Where'd you get the negative 12 from?
Negative 6, and then the exponent 2.
Yeah, we multiply, but it's going to look like this, y to the negative 12, right? The exponent goes up there. We were just doing this over the last couple of days, so that's something that we know. But see how it seems easy, but then we muddle it all up with other stuff and it starts to get blurry, so that's why we take a bunch of days to practice. Is everybody okay with that? I multiplied each of these things, 2 times 2, negative 6 times 2, but the 3 isn't an exponent. The 3 is a base, so that was 3 squared. If you're not all the way sure, ask about it again throughout the day today and make sure that you're getting it. So that, now we have to simplify the negative exponent. Only one part of this is negative, has a negative exponent. So that's the only part that I flip down to the denominator. So what do you think this one's going to look like? It's not 1 over everything to the 4 over y to the 12. Very good, exactly. So see how this part, no negative exponent, stays on top. This part, negative exponent, goes to the bottom. That's important that people know that and see that and understand. Okay, let's try another one. So it starts to get more and more complicated when we get more complex expressions. There's 2 ways that you could do this one. Some of the questions we see are going to be easier to do one way, and some are going to be easier to do the other way, but you could do all of them both ways. And I apologize, but I can't tell you any rule really for when it's better to do one way or the other. That's what you have to do some practice and sort of figure out the way you like to do it. So I'll show you both ways this time. The first way is I'm going to handle the negative exponent on the outside, the negative 2 that's out here. I'm going to handle that first. What does the negative exponent do? Flips everything to the bottom. And because that negative exponent is on the brackets, the whole thing to the positive 2. But again, notice, this is a negative 2 base. That doesn't flip. Negative exponents flip. Negative in a base is totally different. Yeah.
Does the one inside the bracket change?
No, because I haven't used it yet. I haven't done anything with it yet. And because it's in brackets, like I can't really do anything with it yet, so I'm just going to leave it for now and we're going to deal with it later. Does that make sense? And this is why it can be so complicated, because every question is different. You got negatives all over the place. It does get tricky. Okay? But it's doable. It's just weird at first. That's all. You just got to work with it a little bit. Now what do I do with that 2? I'm going to apply it to everything inside the brackets. So again, what is negative 2 all squared? Does anybody know what that is? In other words, is it negative 4 or positive 4? Who's willing to take a chance? Why positive 4? Yeah, because it's negative 2 times negative 2, because it's in brackets. Very good. So this is 1 over 4 p cubed all squared. Whoops, I gave it away. Is p to the 6. So this is p to the 6. And g to the negative 2 all squared is negative 2 times 2, g to the negative 4. So this is g to the negative 4. Are people following or like totally lost and just think this is insane? Sarah, what do you think? Very good. So Ben, this is what you were asking about before. Like, what do we do with that? Now that it's outside the brackets, now I can take care of it. Do you agree? And what do I do with it? Like Sarah said, it's at the bottom. So just that one part flips to the top. So I get g to the 4 over 4p to the 6. When you start to see enough different examples, I hope you start to see the pattern and why we do what we do and that kind of thing. Yes?
Could we just multiply the negative 2 exponents?
Yes, thank you very much. That's the other way that you could do it. I'm going to come over here and do it that way. Or I multiply this exponent into the brackets first, and I would get negative 2 to the negative 2, which is a little awkward, but that's okay. P to the negative 6, g to the positive 4. Do you agree? So then this becomes negative 2 to the negative 2 is going to go on the bottom, and it's going to be negative 2 to the positive 2. P to the negative 6 goes to the bottom. P to the positive 6, g to the 4 stays on top. And it all works out the same. You don't like that? You're okay? What do you think?
Do we have to show all of those steps, or can we just like write it as like -2 times -2 is 4, 4p, -6 is 4, and then when I with the negatives swap it? Like if we just have 3 steps, like that goes.
Okay, I would say you could do this question in 2 steps. I wouldn't try to do it in 1 step. I think you should show a bit more work than that because this question is going to be more than 1 mark. And if you show 1 step and it's wrong, then you lose all the marks. So I would show at least 2 steps for a question like this. As I've said before, it's hard for me to say, like, what do I show? What do I show? Because every question is different. So when we do a learning goal, show the work you think is appropriate, and then I'll tell you afterwards if that was enough or not. And then we can talk about specific examples. And what I will say, when we take up the quiz, we'll take up the quiz in class tomorrow, I think. When I take up the quiz, I'm going to show you a couple things about things you can't do. Like, you're not allowed to say 2 lines are equal when they're not. So you have to make sure whatever you're writing is consistent. You can't, like, some people just do a placeholder. They're like, I'm going to put 4 up here. I know it's going to go to the bottom eventually, but I'm going to write it up here now. You can't do that. But we'll talk more about what I mean exactly by that later. Okay, let's try another one. We only got a few more here. Then we can move on to our activity. Man, these are nasty questions. Huh? (4x y to the 4) times -12 x to the -2 y to the 3 over -6 x squared y to the -3. In this case, oh wait, I'm looking at the wrong question. Sorry, never mind. That's the next question coming up. In this case, I would do the top first, simplify it, then work with the bottom, then take care of negative exponents at the end. So I'll show you what I mean by that. Remember when we did, I'm just going to pretend the bottom's not there, and I'm just going to do the top just like we did in like one of the first couple of examples, in example B. So 4 times -12 is, use your calculator if you have to, works out to -48. This is x to the 1, because when you don't see an exponent, that means exponent of 1. So x to the 1 times x to the -2 is 1 minus 2. Is that right? So this is x to the -1. Y to the 4 times y to the 3, what's that? Alexis, you know what that is? Y to the 4 times y to the 3. Got it. Y to the 7. And then I write the bottom. -6 x squared y to the -3. Now when I'm dividing, what's -48 divided by 6? 8. And positive 8, because 2 negatives makes positive. Very good. X to the -1 minus 2. What's -1 minus 2? Nice. X to the -3. And y to the 7 minus -3. Those 2 negatives makes positive, so it should be nice. Y to the 10. And so see what ended up happening? I only have 1 negative exponent in there, and it's easy to deal with that one. I hope you know what to do. Go ahead and try to do the next step. Excuse me. Who thinks they know what it is? Okay, I'm not going to call on you if you put your hand up. How many people think they know what it is and wrote something on their page? Good. Okay, good. Is this what you wrote? Did you just think to yourself? Yes? Awesome. The x to the negative 3 means the x part goes to the bottom. The negative exponent becomes positive exponent. The rest of it stays on top. Ah, so you brought the 8 down with the x. So the 8 is a separate part. And if the 8 could have had like a negative 1 exponent on it, but it's like a positive, and not a positive 8, but it doesn't have an exponent on it. So it doesn't move. Because this is like, watch. This is like 8 times x to the negative 3 times y to the 10. So the 8 is its own separate thing in this case. Does that make sense? Okay, good. Good question. Really good question. Oh, there's something missing in this example, and it's an x. That's weird. 14x squared over 6p squared all to the negative 2. So the exponent on the outside of the brackets applies to everything on top and everything on bottom because it's all in the brackets. So 14 squared, who can do that? 196. 14 times 14, not 14 times 2. X squared, all squared is? You multiply the exponents, so it's x to the 4. Then on the bottom, I do 6 squared. 36. And then p squared, all squared.
4.
P to the 4, good. No negative exponents in this one, it's a different kind. What should I do? But I do have one more step left. Does anybody know what it might be?
You divide 196 by 36.
What do you get?
Decimal.
A decimal. What's the decimal? What is it exactly? Here, let me do it. So we can all see it. Hey, what's going on?
5.4.
196 divided by 36 is a nasty decimal, so we don't want to do that. So we have to reduce. And I believe I can do 196 divided by 4 gives me 49. And 36 divided by 4 is 9. So I reduced this. Divided the top and bottom by 4. I'm going to tell you a secret. If you have a good calculator, it will do fractions for you, and it's fine with me if you do that. So in my calculator, once I learn how to use fractions, I go 196 over 36. I hit equals, and it gives me the fraction in lowest terms. That's kind of nice. So if you ask me about your calculator sometime later, I will help you figure out if it does fractions and how it does fractions. Because 196 over 36, what a pain to try to reduce that. Like to me, that's just kind of stupid. Okay, this is exactly the same question, except I've got 2 negative exponents in it. So yes, I could multiply this negative exponent through, but when I get negative exponents on the 14, that starts to complicate things to me. So in this case, I would take that negative 2 on the outside, flip everything, and then get to work. But this is just a preference thing. You might disagree with me and like to do it a different way. So 6p squared over 14x to the negative 2. But now it's to the positive 2. And again, you can go back and compare how these are different and how they're the same. 6 squared, we already did that. It's 36. P squared all squared, we already did that. In the last question, it's p to the 4. 14 squared, 196. X to the negative 2 all to the 2. Jada, do you know what that is? So it's x, so it's like this. X to the negative 2. Whoops, that was bad. To the negative 2 all to the 2, like that. How would I simplify that? Why? But one of them is positive. Good job. Negative times a positive is negative. Very good. And 2 times 2 is? Anybody? 4. So we're going to get x. Very good. X to the negative 4. Now what do I do with that negative?
Bring it to the top.
Bring it to the top, and I can reduce. And I'm reducing this because we already did this one, right? 36 and 196, we already did that. So this is going to be 9p to the 4 x to the 4 over 49. Ridiculous, isn't it? All right, one more. Here's what we're going to do. Again, because I have a negative outside the brackets, if I tried to put that on the 3 and the 5, I don't know, to me that feels like that gets really complicated. So I would deal with the negative 3 out here first, and then try to do the rest. So what would the negative 3, what would I do with that? Nanette, what do you think? This goes to everybody. We've been working with negative exponents for a few days now, so you should be starting to remember. It's weird, but what's the thing that a negative exponent does? Nanette, what do you think? Yeah, you flip them, right? Like take the reciprocal, we call that. So I'm going to get 5x to the 4, y to the negative 3, z to the negative 5. So those ones inside don't change because I haven't done anything with them yet. I'm just doing that 3, the negative 3 on the outside. To the 3, to the positive 3, right? So I flip the sign. That's what it does. Okay, now I want you to see if you can figure out the next step on your own. Take a minute and do that. Some people hate it when they just want to copy and they don't want to do it themselves, but this is so important that you, even if you're not sure, that you take a risk and you just try something, and then you see afterwards if what you did was right. Okay, let's try this. I saw a lot of people do this. 5 to the 3, and I just want to point something out. 5 to the 3 is 125. I actually do 5 times 5 times 5. It's not 5 times 3, because 5 is the number, right? So it's 5 to the 3. X to the 4, all to the 3. This is where I multiply. And some people are like, I don't understand. I'm starting to get confused. I thought I understood this. Why am I multiplying here, but I'm doing like something else there? Because this is not 4 to the 3. It's x to the 4 to the 3. So 4 is an exponent. So you're multiplying. 5 is the number, the base. So it's an exponent. Okay, then y to the negative 3. So negative 3 times 3 is y to the negative 9. Negative 5 times 3, z to the negative 15. 3 to the 3. 3 times 3 times 3, what's that?
27.
27, very good. And again, put your pencil down and just watch for a minute. Why is it when I did this 3 and this 3, I got 9, but when I did this 3 and this 3, I got 27? Like, why?
If it's an exponent, when you're multiplying exponents, you just add them.
Yeah, and when you're doing exponent, you multiply. It's different from when it's a number. Very good. Okay, so x squared all to the 3 is x to the 6. Y cubed all to the 3 is y to the positive 9, and z to the negative 2 is z to the negative 6. What would I do next? I would handle the exponents in dividing. When you divide powers of the same base, you subtract the exponents. So I've got 125. X to the 12 divided by x to the 6. 12 minus 6 is 6. I'm subtracting exponents now. Negative 9 minus 9 is negative 18. So z to the negative 15 divided by z to the negative 6 is z to the negative 15 minus negative 6, which is plus 6. So that should be z to the negative 9. All over 27. And then I take those two negative exponents and I drop them to the bottom. Whoops. I said it, but I'm not actually doing it. Over 27, y to the 18, z to the 9.